Point ultraviolet light at a human lens and it stops dead. Almost none of it reaches the back of the eye. The lens in your eye works like built-in sunscreen, soaking up short wavelengths before they touch a single light-sensitive cell. Now run the same test on a cat's lens. A measurable share of that ultraviolet goes straight through. Researchers found this by doing something that sounds almost dull. They collected eye tissue from a range of mammals and measured, wavelength by wavelength, how much light each lens let past. Dogs, ferrets, rodents, reindeer, cats. Several of them turned out to be leaky in exactly the band we're sealed against. So there's light in your room right now that lands on your cat's retina and never lands on yours. The interesting part isn't the light, it's the gap between arriving and seeing. Photons hitting a retina are not the same thing as a picture in a head, and that gap is where this whole story lives. This isn't a ghost story. It's a story about one thin disk of tissue, what it lets through, and what the animal behind it can actually do with the leak. Most of us already assume cats outsee us. The eye shine in a dark hallway, the way they lock onto something in an empty corner. It feels like extra equipment bolted on top of normal vision. That's the assumption worth taking apart. A lens that lets more light in is not automatically an eye that sees more. Consider why our lens filters ultraviolet at all. Short wavelengths scatter easily and carry more energy. They also focus at a slightly different point than longer ones, so letting them through can soften an image. Blocking them buys sharpness and protection and costs photons, which matters little to an animal that mostly works in daylight. For something hunting in the last 20 minutes of dusk, the arithmetic looks different. Every photon counts. We can't rewind evolution to check the order things happened in. What the comparison across species suggests is that heavy, short-wave filtering tends to show up in animals that trade photons for a crisper image, and stays absent in animals that can't spare the light. Take a breath here, because the clearest evidence for what a leaky lens is actually good for comes from an animal nobody puts in this conversation: the reindeer. Snow throws ultraviolet back at the sky with almost nothing absorbed. Against that, certain things swallow ultraviolet instead of bouncing it: lichen, fur, urine. Work on reindeer eyes has recorded retinal responses to ultraviolet stimulation, and the suggestion is that in that band, those objects don't blend into white. They sit on it like ink. Notice what that ability is. Not finer detail, not richer color. Contrast. Dark shapes popping out of a bright field. Where we can actually study ultraviolet vision being used, it behaves less like a new channel and more like a stain that makes certain things stand out. Now carry that indoors, where there's no snowfield and very little ultraviolet to begin with. And here's where I have to be honest about the limits. Measuring what a lens transmits is straightforward. Measuring what an animal experiences is not. Cats can be tested for whether they respond to ultraviolet, and detection is one thing, but no experiment tells you whether it registers as a color, a brightness, or a blur at the edge of a scene. You can't ask a cat what violet feels like. So if you had to bet on your own cat, a sharp secret color or something vague it long ago learned to ignore, the honest position is that the optics lean toward vague, and the evidence can't close the case. The eye is measurable, the experience isn't. That limit is part of the mystery, not a footnote to it. Which brings us to the thing that explains most of what looks supernatural about cat vision, and it isn't ultraviolet at all. Behind a cat's retina sits a reflective layer called the Tapetum lucidum. It's why eyes flare green in a camera flash. Light that slipped past the photoreceptors on the first pass gets bounced back for a second chance instead of being wasted. On a near-dark night, that second chance is enormous, and it comes with a cost. A mirror sitting behind a screen doesn't send light back to precisely the point it left. Some of it returns slightly off target, and the image smears. Combine that with a retina packed with dim light receptors rather than fine detail ones, and you get an animal whose measured acuity is far worse than yours. Think of the chart at the optician's. Your cat is stuck several lines up. Its color world is narrower too. Behavioral testing supports something closer to two-color vision, where reds and greens collapse toward each other and a lot of the vividness you take for granted isn't there. This reframes the whole question. Cats didn't receive a bonus, they made a trade. Sensitivity was bought with sharpness. Motion in the dark was bought with color. The ultraviolet came along as a side effect of an eye that couldn't afford to throw light away. Nothing invisible was added, something visible was given up. So, does a cat see things you can't? Yes, but the list is shorter and stranger than the internet suggests. It sees usable shape and movement at light levels where you'd see a gray wall. It catches motion at the edge of a room before you've worked out what moved. And a slice of ultraviolet reaches its retina that never reaches yours, in a form we can measure but not translate. What it doesn't have is a clearer view of your world. Ask a cat to read a label across the kitchen, and it's helpless. And when it stares at a blank wall, ultraviolet is the least likely explanation. A cat's hearing runs far above your ceiling. Pipes settling, insects inside plaster, electronics whining away. The wall isn't glowing, it's talking. One last, very small thing. Laundry detergent contains optical brighteners, compounds that drink in ultraviolet and throw it back out as blue. That folded pile of clean towels on the chair is, in ultraviolet terms, one of the loudest objects in the room. Your cat will sit on it, not because it's blazing away in a wavelength you'll never see, because it's warm. If you've watched a cat lock onto nothing, which would you put your money on? An ultraviolet smudge on the wall, or a sound in the pipes? I'd like to see how that splits. And if you like animal questions where the answer turns out to be a trade-off instead of a superpower, there are more of those coming.